Getting quickly now into the corona discharge section, and we'll get into details of how that works and why it's done. This is a fan that they had here, and it was sucking from inside. I've already taken out the 2 bolts, so this is lift straight off, 24 volts. As we saw, this entire thing is 24 volts. One of these nice little squirrel cage, I call them, type fans, and it's a pretty good discharge out. So I'll find a use for this for sure. Belt system, some gears. We'll have to open this and see. That's just probably just in these rollers here. Actually, it's just in the rollers. Nothing too fantastic in there, but yeah, screws, so you can get in there. On to the next side now. What we have, and this is probably going to be difficult to see. Wonder, can it be seen? That there, and this here. You could hear it. It's almost like a guitar. Those are 2 corona discharge wires. I will get into the details of that. I've actually gone through the effort of drawing a diagram so I could remember it a little bit better later on in life. But I'll explain exactly why there's 2 here and there's one somewhere else in the system I have not seen. Then there's this wire here. I'm not sure how easy it is to read this. Probably not that well from the phone video. Anyway, I have a good picture of it. I will jump into that and show what it is. Apparently this proprietary wire, it's made by Sumitomo, I believe. I'll have to check back that when I get the data sheet up. And it is E41105, I believe, and rated at 30 kilovolts DC. As you would expect, these wires have a single plug. It's a single wire in here, and I bet if I cut this, the wire inside is pretty small, so we're going to cut it because I have no real need for high voltage, nor am I going to do that. And let me get to the actual high voltage board now. Into the board, this was some high voltage transformers, another one here, but these are flyback transformers. I probably shouldn't try something metal too close to them. Maybe that's not the best idea. I'm not seeing any caps except these small caps, so maybe it's not that dangerous. But there's a high voltage transformer here. There's another one here, flyback transformers, and a third here, and they all have a single output pin. Looks like mouths, and there's milled parts to avoid discharge over. So it's pretty good design, nice system, and there's at least this in here 3, 1, 2, 3 of these, and that makes sense. And we'll describe in detail exactly what those 3 corona discharge wires do. There's a bit of passives on the other side. I'm playing very brave with this. A bit of passives and a bit of, I guess, I don't know, maybe those switching, maybe the quarter pumps, who knows. I could get into it, but it's probably not going to be able to figure out all the details of this without some effort, and I'm not up to it right now. And as to why this board is on the side like this, I don't know. I really don't know why this board came up. Maybe they didn't have enough space and they thought it was easier just to do these connectors this way and just do the board on the side. That's one for Xerox. Pretty disassembled now. This little piece is on here. I could probably take this off. This is basically just the whole housing. Nothing much there. This is the other piece on top where the fan was. That came off fairly easily. There's a rod in here which is fairly rusted, so not too sure that's useful, but it got some embedded rubber on it, so if I'm doing any projects with rubber, maybe it's useful. A couple of gears there. This is the high voltage part, and if you look, it's potted with silicone because it's soft and goes in, and has a high voltage wires. It went to 2 spring leads, and those 2 spring leads went to these 2 ends here. As we expect, the wire is in fact tensioned with a spring, so there's actually 3 wires here. I thought it was 2, but now that we've opened it up, it's clearly 3, but these 2 are joined. So there's 2 together here and it's joined. So that is essentially electrically 2 leads, but 2 of them joined together here and 1 underneath here. So that probably is where your page discharges again. So this is probably the one that touches and takes off the charge with that here inside. And the wires, let me grab hold of one of them. Right, get into the wire here now. I've got it, and as I expected, one of these stiff plastic layers inside, and then inside of that stranded wire. I didn't think I would have so much strands, but it seems we do, to get the flexibility, the bending that they're looking for. So that's the wire. Let's jump straight into the details of the wire, that high voltage wire, and then we'll jump into the whole mechanisms, why these wires are here, what they do in the overall scheme. This is the best wire spec I could have found. It's clearly Japanese, Sumitomo Electric. I always thought they only made tires, but I guess they make other products too. Well, there's enough English in this anyway to understand. So having a look on top, we can see that it does state the E41105-M, and this one is just saying the 105 volts, typical 20 kilovolts, but we had a 30 kilovolt one. So let's move on now onto the actual photocopier corona wires. Starting at the center of this illustration, we have the photosensitive drum, well, the drum with the photosensitive material in it, selenium, and that drum is charged now, if you look above that, by the primary corona wire. That's the one I did not find. And when it's charged up to give or take 600 volts. That's what I got from one source, but I guess different manufacturers, different sources, different views on this, and positive and negative different views on this again. And as it's charged up, the laser then, and you look at the direction rotation is anti-clockwise, the laser hits against a mirror, comes on and off, and it scans across the surface of this drum. As it's doing that, where the laser hits, it discharges. It becomes conductive, and it discharges to the aluminum below, the base of the drum. The areas that aren't discharged, as they pass now by the tuner, they attract the tuner, and the tuner sticks on to those areas, and those areas alone. As the drum continues rotating, the paper is coming across, and you can see the arrow. Paper is going from left to right, and the paper is charged by the transfer corona wire. Charges the paper at a potential opposite to that of the toner, and what it causes the toner to attract and go onto the paper. After the paper passes and the toner is now on the paper, we need to discharge the paper so it doesn't remain with a charge, and that is what the detach corona wire does. That discharges the paper, and the paper then transfers right after and goes into the fuser, which basically melts it. Toner is really plastic with iron oxide in it, so it essentially melts and fuses like plastic onto the paper. And then coming back up now, we have a discharge lamp. That's a lamp that basically puts out enough light to cause the entire drum at that position to go back to zero charge. So essentially it resets the whole thing, and it rotates up to the top, and the whole process starts over again.